All right, Trig unit test preview. Number one. Again, like we've had before, you will have some helps as we're going along on this, so I'll mention those as we go along. I haven't figured out yet if you're going to have a cheat sheet or if I'm going to have stuff up on the board like we've done before, but you will have some help with some things. Okay, we're actually going to start at number 2, because these first two are doing the same concept, but I think number 2's got a little twist that we want to make sure we catch on here. All right. So from the top of a 160-foot tower, the air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Now here's what gets tricky, because you're like, well, to do anything with Trig, I have to have some angle that's inside here, and it doesn't look like I have one. But I actually do, because this angle of depression that they talk about here, we're gonna do some old school, go back to geometry here for just a minute. I'm gonna zoom a little bit more here so it's a little bit easier for us to see as we're going along. There's this thing, when you have two parallel planes, and we do, literally with an airplane problem, it's kind of funny. Two parallel planes that are cut by a transversal. It makes this Z shape. The alternate interior angles are always congruent. So whether you see the words angle of depression or angle of elevation, this is the same place the angle's going to end up, this 19 degrees in this case. So now I can do my thing. So let's see here. If this is my angle, this would be my opposite. And always across from the right angle is my hypotenuse, because that's always the longest side, which means this has got to be adjacent. So what does that tell me? Well, I have a number at the opposite side, and I'm looking for the adjacent side. So which one of my trig functions is opposite and adjacent go with? Tangent, right. It goes with this one in this case, because I've got these two sides. So I'm going to have the tangent of 19 degrees equals opposite over adjacent. Okay, that'll get me set up at least with my expression. And I've got to watch the order because the order matters. I can't flip them and get the same answer. So if I'm trying to solve this, there's a couple of ways we can do it. We talked about a pattern before with this where if x is on the bottom, I end up dividing by this. But let's do it mathematically just so you can see how this works. So if I want to get rid of the fraction, I got to multiply by whatever's in the denominator, which is x. Now it's going to look strange here at the start, but just stick with me. It'll clean itself up here. You're like, but that didn't get me x. I'd rather just done the 160. Well, that would have been nice, except that wouldn't have gotten me to the right answer. And so now that I've done that, what's my one step to get x by itself? Got to divide by that tangent. So now this is what I type into my calculator, but here's the thing, and you've got to be careful, especially if you're using a calculator in here. We've got classes doing different things right now. Okay, my honors crew may have these things in Radian mode, and since you guys are right at the beginning of the day, it may not be fixed. So like here, see, that'd be bad. We need to be in degree mode, otherwise our answer won't come out the right way for us. So once I'm in degree mode, I can do 160 divided by the tangent of 19 degrees. And again, normally with these, we just will go to the nearest tenth. So, okay, a little under 465 feet away would be that distance. And that's a sensible amount. If I got like 10,000, probably not a real sensible amount. Might give me an idea that wouldn't work. All right, so let's see what else we got working here. Which of the following are coterminal with the angle 45 degrees? Circle. All that are correct. Coterminal. Coterminal is when something is 360 degrees away. In other words, if I did a complete circle and ended back up at the same angle. So what I've got to figure out with these is, if I start at 45, which of these angle measures are going to end up there. Now, to me, the easiest way to deal with that is to go to a calculator and say, okay, yep. And I can either look for individual ones, or I can just start saying, okay, I see a negative one there. Let's see if I can get there. So if I do minus 360, that's negative 315. Okay, negative 315. That one worked. If I minus another 360, oops, that's too big. Okay, so negative 495 doesn't work. But then I also see positive ones. So I start, adding 360. Oh, 405. Okay, 315 is smaller. That one didn't work. So it really looks like now I just got to check to see if 1125 works. And it does. So I get 3 of them. My biggest thing there is that I got to remember it's 360 degrees. Because if I try some other numbers, that probably won't get me to the right answers very well. So got to remember coterminal is 360. Sketching. And I have this funny feeling I'm going to need to find some more of the protractors again, because some of you might have misplaced them. I do have about 10 or 15 of them that I've got up by the projector here. If you need to, when we're doing some of these in class, if you need to borrow some for now, that's fine, but they need to be put back at the end of the hour, and I'll get some more made before we get to the test itself. But I want to look at number 5, because number 5 is weird. You're like, negative 145. Big thing to remember here. When we're doing negative angles, okay, when I'm doing positive, even though we're not going to do 4, when we go positive, we're going counterclockwise as we work our way around. So I'd figure it out that way. Well, this one works a little bit differently. Since I'm working on a negative angle, my numbers actually go the opposite way. They're going to go clockwise. So the negative does make a difference. So I look and I go, okay, negative 145. So if I started working my way along here, I'd be like, okay, there's negative 90. Ooh, negative 180, that's too far. So maybe I look at this and I go, okay, there's a couple of ways I could do this. Since it's negative 145, so there was 90, I can just kind of work my way out to where that is. Get my angle ready. And finish that off. Now, your question may be, and I may adjust a little on what we're going to do with this then. Your question may be, well, okay, that's fine. If it's between 0 and 180, I can just do it on here, but what if it isn't? What if it is like number 4? And I'll come back to the reference angle on this one in just a second. So what if it's something like 305? What do I do? Okay. So if it's 305, I'm like, okay, so I'd have 90, 180, 270, but if I went all the way to 360, that's too much. To get from 270, where I'm at right now, to 305, how many more degrees do I need? For those of you that couldn't hear that outside, I was just told I have a calculator, to which I'm going to respond, and you all have a brain. So I will use my brain here, which hopefully some of you will use your brain when it comes to the test. That'll be 35 degrees. So whichever axis I stopped on, so I stopped on the y-axis, I line up with that one, and then oh wait, no, all you see is my hand. Okay, so unfortunately, might be a little bit trickier for some of you to see, but I think you still can. Here's my 35 degrees, and I would go ahead and add that on to the 270 that I already have. And that would finish off my angle.
Some basic common sense here.
Yes, it would be some basic common sense to kind of say, okay, if I got this much already and I need this much more, let me kind of see where this is at. So let's get back to this whole idea of a reference angle, though. Okay, reference angles. Reminder on what those are. It's me trying to get back to the closest part of the x-axis that I can get to. So for instance, on number 4, the closest x-axis would be this area right here.
Finding what's left.
Yes, you're saying if this is 305 to here, and the closest x-axis I can get back to is 360,
So it's 360 minus 305.
it's 360 minus 305. So my reference angle would be 55 degrees. But it's got to be the closest one. So you look at 5 then, if we use that same theory, okay, here's my negative 145. Closest one gets me back to the 180. How far away am I? Okay, now here's the thing with the reference angle, because you'd think it's negative 35. But it's regular 35. Reference angles, correct, are always positive, even if you're dealing with negative angle measures, because again, a reference angle just refers to a distance, okay? So we're not looking for positive, negative with that. So there's a couple of things kind of working there that I've got to keep track of. A lot of what we're starting to see with this is, it's going to be, do we understand the terminology to be able to answer the question? Because it's not that the questions are that crazy difficult, it's just trying to get used to it a little bit. Okay, we are going to make an adjustment, and then we're actually going to do the one we make an adjustment to. We're just going to be dealing with sine and cosine stuff on this. I'm not going to make you do secant. That's kind of, yeah, that's kind of crazy of me to do. So that's sine. Okay, so find the value for the following trig functions. Sketch the angle in standard position, and then use special right triangles to find the exact value. Okay, so sine of 225. So we just got done talking about if it's a positive, it goes counterclockwise here. So again, I'm not looking for perfection. If you want to bust out your protractor, you can. But 225 gets me, right about here. It's more than 180, but it's not a whole lot more than that. So we'll call this 225. So now, we're trying to figure out what this value would be. And what we had actually done before, and I'm trying to see if that's what I'm trying to shoot for here. I'm trying to think of what I'm doing to you on the test and what I'm asking for here, just make sure I do the right thing. Okay. That's the ones we're doing. Okay. So, we make our triangle back to the x-axis, never to y, always to x. Get my right angle in there. So here's the question I've got for you. How many degrees is this angle right here going to be? It is. That's not the triangle we're going to get this time, though. So if it's 225 all the way to here, and it's 180 back to the axis, I've got a 45, 90 triangle. So what I'm attempting to do here is once I have that, now I've just got to remember, and I'll move this down a little, because like Rena was mentioning, here come my 30, 60, 90 and my 45, 45, 90 triangles. And if we remember back, and again, this will be something that'll be there on your help sheet to get you some guidance. When I'm doing 30, 60, 90, my pattern sets up with my side opposite my 30, my short side being x, long side being x squared root of 3, and my hypotenuse being 2x. And with a 45, 45, 90, it's x, x, and x squared root of 2. But again, you'll have this in some format, so it's not like you've got to have that memorized. You're like, okay, so how's that help me figure out what I'm looking for? Well, once I know that it's a 45, 45, 90, okay, typically we just use ones if there's not something there for x. So 1, 1, 1 square root of 2. And then, since this is my reference angle, my angle, Which sides do I use for sine? Which sides am I going to need for sine? Opposite over hypotenuse. So opposite over hypotenuse. Ruh-roh. What's my one issue here? Yeah, we can't have that radical in the denominator. We got to fix that. That won't take long, though. So we do square root of 2 over square root of 2. And now we're in business. So again, it's not that any of those steps are awful. It's just trying to keep track of what I got to do, okay, to be able to find that value. Okay, but that's probably one of the more tricky things we're going to take a peek at here. Okay, let's see what else we got. Convert to radians or degrees. Oh, yay. All right. When we're trying to go from degrees to radians, we put the pi on top because pi and 180 are equivalent. 180 degrees is pi when we're talking in radians speak. But remember, when we're doing this, we're going to want to simplify, and we're not going to stick the pi in the calculator because that's not the pi we're looking for here. So what I can do is take the part that's not with the pi, 160 over 180. A little math enter action. And reduce it down. If I'm going the opposite way, though, okay, if we're going from radians to degrees, that's right, we just flip the fraction over because then the pi's cancel. That's always nice. And then I do 3 times 180 and divide it by 2. And I get degrees. So again, nothing awful. Just got to keep track of a few things. All right. Oh, story problem. Okay. This one we'll have a chat about. If the minute hand of the clock is 11.5 inches long, how far did the end of the minute hand travel from 7 a.m. to 11 a.m.? Use the formula. S equals R theta. You're like, what is that again? That's my arc length formula. And we'll talk a little bit about the pieces of this. Okay. How many revolutions, how many full circles does the minute hand do from 7 a.m. to 11 a.m.? So you're like, okay, let's see. 7 to 8, that's one time around. 8 to 9, that's 2. 9 to 10, that's 3. 10 to 11, okay, 4 revolutions. You're like, okay, so what's that mean? That's like a cycle, okay? So when you do a complete revolution, how many degrees is that? Okay, 360. Here's the kicker, though. We need to figure out our angle measure in radians. So, if we go with degrees to start, which you could, unless we figure out how many degrees 360 degrees is in radians. Well, we'll talk about that. Okay? Now, I could do pi over 180, and when I simplify that, I find out that 360 degrees is 2 pi, because 360 divided by 180 is 2. And then I just do that times the number of revolutions, and I get my angle measure, my theta, which is 8 pi. So you see, I had to do a little bit of manipulating there. Not too bad. So then the arc length is just my radius times my angle measure. And this time I actually am going to plug the pi into the calculator, because who goes up to somebody and says, hi, this is 92 pi inches? Nope, nobody talks that way. So you could type in 3.14 if you don't remember where the pi is. And the pi is just second in that up caret. But yeah, 3.14 would work fine. So about 289 inches. Okay. Normally we just go to the nearest tenth, and that would be the nearest tenth here, but it's all good. Okay. So for this last part, oh, we've pounded this stuff. Identify the following features of the trig graphs, then complete one graphing cycle. I am going to do C. So I am flipping A, B, C. Because this is the most recent thing we have been dealing with, and I want to make sure we do this right.
They don't have the amplitude of
Okay, so now, if I don't see a number in front of sine, if I don't see a number in front of the angle,
That's not what I'm asking. I'm saying, do we have to find the amplitude and period because they don't.
you don't have to write them, but I'm going to here, just as a reminder.
So the amp would be 1,
My amplitude would be 1. And what would my period be?
2.
2 pi, because there's no number in front of my x here. So if that's true, if none of these change, what's that plus 2 mean? We're shifting up 2. Okay? So like we did before, I would graph this without the up part first. So we still have to have our 5 points. So I know I start at 0. And since my period's 2 pi, I know I end at 2 pi. Now I got to figure out the values in the middle, which for some of us has been a struggle. So it's good to see this again. 1 pi, because 2 is in the middle, 1 and 2. I'm with you. Okay. In between 0 and 1 is a half, so pi over 2. And 3 pi over 2. Now again, if that didn't click for you right away, here's an option. Most of you, I'm hoping, are okay with in between 0 and 2 is 1, in between 0 and 1 is a half. And again, if you just look at that as I'm adding a half every single time, and then reducing it, 2 over 2 is 1, 4 over 2 is 2, and the 3 over 2 didn't reduce. That's where that came from. So then, one last thing. Since our amplitude is 1, we know that these will be 1 and negative 1. We're going to have to expand this a little bit, but we'll chat about that in a second. Where does sine start normally? 0. So we'd go 0. Yeah, it goes to max unless there's a negative in front. So I get those, but again, don't connect those because those are just my reference points. We got to go up 2. So yeah, we're having to draw extras because Harty didn't think ahead. It would have been easier to put them down here, but you know, that's how it goes sometimes. So, you're ahead of me then. So I take each of these and I shift them up 2. And then I can connect the dots. So I just took a regular sine graph and shifted it up 2 for each one. Okay. Yeah, it looks a little strange since my 2 and 3 lines aren't equally as spaced as my 1 was. You're kind of looking, you're like, you're kind of looking at it that way. And that kind of gives us those types of values too with those shifts. So kind of get to play with those. There'll be some amplitude changes, some period changes, and then another shift problem. So then, we're almost there. You're like, dang, we've actually done quite a bit of stuff in this unit. It seems like we've been graphing forever, but we've done a lot of other things too. So on the back, we're going to take a peek at B, because I think that one's a little trickier. Write a sine function for the following graphs. Okay? I'm not going to be mean and put the up and down shifts in these. Just we're going to be looking for amplitude and B value with my period. So, how do I figure this stuff out? A is probably the easiest thing to figure out. What's my A value going to be? Okay, I agree with part of that. Okay. Normally I would just say 3 because you're like, well, here the top is 3. But it opens down to start, and the only time that happens is if I have a negative. Now the B value, remember, that's the number of periods that we have in 2 pi. So I look at my graph and I'm like, okay, well 2 pi is out here. So I got to figure out how many periods are here. So I'm like, okay, well I start at 0. So I go down and up, back down. That's 1. Yep, I go down and up and back down. That's 2. So my B value is 2, because that's how many complete periods I have.
Plus
So y equals -3 sine 2x. Done. That's all we got to do. Once I know how many, how many periods. Oh, Harty. Cycles, Harty, cycles. I don't need to be making more notes on my YouTube page on boo-boos that I make. Cycles that we have in 2pi. My apologies on that. I can understand. Because you're like, wait a minute, that is the period. Why am I asking for that? Okay. And then the last one, we're going to stretch your knowledge a little bit. And again, you'll see this again on the review, so I'm not worried about doing the one that I have here with you. Sketch 2 periods of the given trig function. Okay. So I'm going to do 1 period first, and then we're going to talk about how we can expand it. So you're like, okay, what do I know here? My a value is -2. Now again, that just reminds me that my first move is going to be down. Ooh, excuse me, thank you. And my b value is 1/2, right, which means my period is 2 divided by 1/2, which means I'm going to multiply by 2, because I multiplied by the inverse. So 4pi is my period. So I know that's the last value of my first cycle. 2 is in the middle of 0 and 4. 1 is in the middle, and then there's 3. So when I go to graph this, and there's nothing fancy going to be going on with the shifts, so I know I can just put in the 2 and the -2. So right, I still start at 0, because even negative isn't going to move me from there. But instead of going up to start, right, the negative is going to bring me down and up to the max and back down. That would be my first period. But now I need to keep that going, which shouldn't be hard. You just keep the pattern going. 1, 2, 3, 4. I wonder what's next. 5, 6, 7, 8. You're like, okay, but how do I get the rest of the graph? Just keep doing the pattern. 0 min, 0 max, 0 min, 0 max, 0. Just expand it out to another one. And even if they were fractional values here, we've shown before how I do like 1/2, 2/2, 3/2, 4/2, so just keep doing that, 5/2, 6/2, and just keep doing the same thing, okay? So again, knock out the rest of these, kind of see how they're going. And over the next couple of days here, we're going to be doing some more review stuff like this to make sure that we just pound this one down, because this unit test will be the last grade that goes on before, yes, progress reports for 4th quarter go out. So the end is coming near. Let's make sure things are going good.